Hi class, let's take a look at input validation loops. We will use these to do exactly what the title says. If we receive some input from the console, let's validate it. We can validate it for a number of attributes. One is to check its proper range. One is to check if it's properly formatted, if we've got the exact right character. Another would be to check if it's the right data type. If we want to get an integer and we receive a double, that usually will cause the program to crash because there is a mismatch in data type. But we want to be able to handle that. So these are the types of things we'll use input validation loops for. Now, these will always be a while loop. Those are best set up for input validation loops because as a pre-test loop, there's the possibility that the condition for entering the loop isn't met. And that means that the entry was correct, in which case the loop doesn't execute at all. And that makes sense. If we make a correct entry, then we just don't need to go through the input validation loop. Now, the condition here that the while loop will have is always going to be describing what's bad. Okay, so remember that. What's bad is going to go into here. So if we're asking a user to enter an integer that's greater than 5, well, then let's draw a number line here. And we want this area to be input. So this is the okay area. This is the bad area. Anything 5 or less is bad. And we would like the user to enter the correct thing. Well, before, the only tool we had before was basically an if statement. And that got to some very lengthy if-else clauses, basically saying, if there's an error, give a quick message, otherwise do the program. Well, now we're going to change that strategy completely and just stay in the program and stay in a loop until the entry is correct. So for this example here, how would we code the bad condition of 5 or less? Well, that would just be, why is this doing that? I don't know. It would just be then while entry is less than or equal to 5, then we'll do all of this stuff here inside the loop. Now, what are the things inside the loop? Exactly 2 things. One is a clear error message back to the user saying what the problem is and what the expected behavior needs to be. What's the best value? What's the accepted value? We've got to instruct the user there. And then second, this is most important, the user's got to be afforded the second opportunity to enter their value. They have to be able to correct their mistake. If you don't have this CN in there, then it's going to result in an infinite loop because the variable entry will never change and therefore that condition will never change. So let's take a look at this in some code and it'll make a tiny bit more sense. And here's some demo code that supports that. First, we have our prompt and our input right here, standard part that must be present. And the first prompt and input is always outside of the while loop, outside of the input validation loop. Then before we did do if this happened, then let's do this stuff. Otherwise, let's go and do the rest of the program. But we don't have to do this now. This basically says to the user, if you use the if statement, that you've got to stop the program, run it again, and do the correct input. This is going to allow that same behavior to happen, except we don't have to terminate the program. So putting a while loop in there will keep the user in there until we get an input less than 5. So here's a 20, and that was fine. Now let's do something much less than. Here's a 3. And look, we get the error message saying, oh, less than 5 only. And you'll note that we will stay stuck in this loop until we finally enter something greater than 5. So that's the beauty of the input loop, input validation loop. Now let's check how to verify that a number is in a range. For example, let's say we want now for them to enter an integer between, how about -9 and 9. Let's try that. Well, let's now program, well, what is the bad condition? The bad condition here, well, there's going to be 2 of them. One is if it's going to be less than -9, and the other is if it's greater than 9. So let's just code those in. If entry here is less than -9, or if entry is greater than 9, then we'll hit the error condition in that point. Let's scope out our error message there and run this, and we'll see that we will get that behavior of 5 is in the range, and we successfully ended. But 50 is not, 55 is not, and we stay stuck in here until finally we get some success. So that's how to check for a range. It's checking 2 specific relational expressions connected by a logical operator. So we'll always check for this or this. Now things get a little more complicated when we're asking them to enter a specific value in. What do I mean by that? Well, let's say we don't want them to enter, let me fix this real quick. Let's say we want them to enter not a number, but a Y or an N, a yes or a no. Well, let's take a look and see how we would do this. Let's correct the error message first. YN only is a good error message. And now let's figure out, well, what do we do here? Now, in this case, we're testing, for something being not what is expected. We're expecting a Y, so we're going to test if it's not a Y. So what we can say here is if entry is not a capital Y, now our minds would think that we would use an OR here to go then and test for the capital N. But surprisingly, because we have reversed the polarity on the not equals, then surprisingly, we also have to reverse this polarity and flip that OR to an AND. Let me first show the behavior if it's an OR. Enter a Y or an N. I'll enter a capital N. And you can see that we are stuck in this loop forever. And that's just because of the way that the logic plays out here. If we enter an N, then we're asked, let's first evaluate this. Is the entry not equal to capital Y? Is that true or false? Well, that's true. Then let's evaluate this one. Is the entry not equal to capital N? Well, it is capital N, so that's false. So in this case, when we enter a capital N, this reduces to while true or false, and true or false evaluates to true, and then we get a loop that's while true, even if there's a capital N entered. So that's why we have to flip this polarity as well. Now it'll work. There's a Y and it works. There's an N and it works. And then let's put in something else and it does not work. A 4, a W, and finally an uppercase N. And of course, let's be good citizens. when we code, we're not heathens, and we will allow users to enter either upper or lowercase. So let's get into the habit of doing this. Either two upper or two lower, whatever you're testing against. And then remember that we'll convert it up. Now we will get the capability to enter lowercase, and it's accepted just fine. So those types of input validation loops, and these are sort of the everyday ones, ones that you would use on the fly every single time. Now, in some applications, there are going to be very memory sensitive requirements. If your application is just incredibly prone to memory issues, and memory could cause an application to terminate early or to crash, then you'll probably want even more bulletproof input validation. And this is the REPL that I posted on the page here. And what this does is it adds in cin.fail. And cin.fail is a special flag that gets raised. If the cin object, when it's reading something in, if it ever encounters any error whatsoever, it raises that flag, cin.fail, something failed. And then we can go and do error handling based on if the flag's raised or not. So if the flag is raised, well, then we can look at, rather than the program crashing, let's just give an error message and let them enter it again. Now, this will always come into play if, say, you are expecting an integer input and you get a character that will cause the program to crash. Or you are expecting an integer and you get a double with a decimal place crash. Cin fail is going to prevent that, because it will make sure that the data type of whatever was entered is going to match the data type of the variable that's going to hold whatever was entered. They have to match int, double, double. So that's what cin fail is going to check for. If we did have a failure, well, the first couple of lines say, all right, we've got a little bit of housekeeping. We're going to clear the flag, going to lower that flag down, and then let's clear the keyboard buffer. There's bad juju in there. Let's get all of that out of there, and let's start over. So check out this lab as well. Check out this code as well. And in our final lab in this module, just remember that input validation parts 5 through 9 will all require this special bulletproof input validation coding with cin fail. All right, I think that's enough damage for now, and good luck, and please pop your questions up in the discussion board. See y'all later.